Hey, what are you doing today? Hope you're having a good day today. I want to be here. This is My Estes Matt. Mr. My Estes here, and I would like to go over with you just how to use GeoGebra, because, that's a lot of my videos on here are how to use GeoGebra for statistics. Maybe I'll do some other things you can use GeoGebra for, but stats is what I teach, so that's what I'll keep doing. GeoGebra for a chi-square goodness of fit. This is going to be a very short video, less than a few minutes, just to show you how to go run through this. But I did want to show you from my previous video. So I did a video on chi-square goodness of fit, and I used this example of cashews, almonds, and macadamia nuts. And here is all of the work that I did on that video. So if you want to see that video, you just go ahead and I'll have that video linked at the end of this video, or you can go look it up, chi-square goodness of fit. So this is a chi-square goodness of fit, and I want to just show you how I could have entered this into GeoGebra to give me the p-value and let me know whether or not to reject the null. So I'm gonna go to GeoGebra. I'm gonna click on. I like using GeoGebra Classic. I say that every time, but that's what I'm gonna use. So I wanted probability. I'm going to go to statistics, and I have chi-squared goodness of fit. Here are my two chi-squared tests here. I think you might be able to access the chi-squared goodness of fit test in the spreadsheet as well. But if I find that, I'll have another video on that. All right. So you have this, and you have a goodness of fit test. We want to know what our columns are, so we need to go back to our problem, and we have, and you know what, if you can't quite see this, this is cashews, almonds, macadamia nuts, and peanuts. So we have 4. All right, so we're gonna add one here, 4, and if you want, you can even type in here, cashews, almonds, macadamia nuts. And what were the other ones? Let's go run back here real quick. Peanuts. Which, ironically, weirdly, only 3 of these are actual nuts. The other one is a legume, right? Okay, observed count is what we observed in our problem itself. So we have to calculate these out. I already made my table here for my third condition. So I'm just going to type these observed amounts in there. So 83, 29, 20, 18. I'm also going to put my expected counts in here. So in my table here, I did the expected counts. I figured that out by doing the total number, which was 150, times the percentages to find each of those expected values. All right, and then I can calculate my chi-squared using the formula, or I could use GeoGebra, which is the point of this video. And so on this video, once you type in that last one, you hit enter. It'll give you both the totals. They have to match up, by the way. Goodness of fit, here's my result. So I have 3 degrees of freedom, obviously, because 4 minus 1 is 3. My chi-squared value calculated is 8.6, which is what I calculated here, 8.608. And my p-value is 0.035. So p-value is 0.035. That's how I calculated this guy right here on this side. Since my p-value is less than my alpha level, in this case of 0.05, I will reject the null, which means that there is evidence that the distribution of nuts here is different than what the company has claimed, because this was a goodness of fit test. All right, that's it, guys. That's all you have to do to use GeoGebra for a goodness of fit test. See you next time. Oh, let's go this way. Boom, now I can say bye. Bye. Don't forget to subscribe. See ya.